Hi there. I'm Novi Shartuk. I'm the project manager for Walktime Error.
I'm Sean Silva. I am the lead UI developer for Walktime Error.
I'm Ricky Lee. I'm the SmartBulb API developer for Overpowered.
I'm Cynthia Khan, and I am the database admin for Overpowered.
I'm Kai Mello, and I'm the lead web developer for Overpowered.
Walktime Error is currently involved in developing Overpowered, which is an intelligence system by which clients can reduce their utility bill through provided data analytics and integrated hardware systems. It is for business clients and universities, and it is web-based. To talk a little bit about some of our functional requirements, we're going to start things off with Sean.
So our first requirement is to obtain the utility data and implement that from the database.
And then Cynthia.
Yes, our requirement 2 is the database functionality, where we create and configure the database server, MySQL server, and input utility data into the database.
And then Ricky.
For requirement 3 is registering profile parameters, just basically inputting utility data and registering smart devices.
And Caillou.
Requirement 4 is register users to the website and just making sure they have access to their SmartBulb's profile and dashboard.
Back to Sean.
Our sixth requirement was to ensure that the website has all the aesthetic values that we would like it to have.
Over to Cynthia.
And requirement 7 was as the machine learning package that we're offering, which will tell the user if the current consumption is high or average.
Over to Ricky.
Requirement 8 is the SmartBulb API functions, including like registering lights as well as turning a remote turning on and off and brightness.
Back over to Sean.
And our last requirement is to integrate data visualization through the form of Tableau.
Our non-functional requirements, I'm going to go ahead and steal your thunder a little bit here, Kev. Our website needs to look pretty, and also the bulb control functions need to be reliable and perform well. So as you can see from our context model, we take as input archive utility records, as well as SmartBulb information, active wattage output. All this information is going to be integrated using Apache server, our overpowered website front-end and front-end scripts, and back-end is stored on GSU Walktime server. From there, to talk a little bit about the use case diagram, we have Ricky.
So basically, our use case diagram just lays out how the user uses our website. The user has access to a login or register a new profile, as well as going to the display dashboard. Along with this, there's like trees of functions that we have added, like redoing profiles, registering smart devices, as well as the machine learning aspect where the display dashboard will access the database to get data analytics, as well as use machine learning to tell if they're using power or overusing power or underusing power.
And we see the smart bulbs in the bridge system, as well as the client themselves, as an actor.
And to demo how the MySQL database is connected to the website, so when a new user registers, the information is recorded in our employee table. As you can see, each user, their first name, last name, user ID, which is the email address, and a password, which is encrypted, is getting populated into the database along with the time that the entry is being recorded and their employee ID. And for Tableau, where we have information about the building name, total usage for the building, the provider, and the date for the record. Now, for our machine learning package, we have data that is the time of the day and the usage corresponding to that time. To that, we have added labels using a Scala script, as you can see here, to make it a supervised learning. And we have used classification, a decision tree model, using our Python script, which will throw messages, alerts every 15 minutes, telling the user if it is high usage or an average usage.
All right. And then to show you how all this, the machine learning and the database, I suppose this is the back end, goes into the actual site. Here's our actual site.
All right, here you'll see the login page, and let's try registering a new user, John Doe at gmail.com, password, click register, and the two passwords do not match. So let's try that again.
An incredible feature.
Incredible feature. Don't save. You're not registered, so you just go log in. And you'll be brought to the dashboard page.
Which Sean will discuss the
In
implementation
greater
of that.
detail.
Here we have the Overpowered dashboard. It has a Gantt chart that shows the buildings on Georgia State's campus and the energy consumptions. It starts from the most used energy consumption to the least over here. There's two legends that depict the different graphs. We have a line chart and a bar chart that show the different energy consumptions as well. We also have another bar chart that shows the total bill amount for the 2017 to 2018 year. As you can tell, the July 2017 and May 2018 were the best months. And lastly, you can also flicker between the bulbs, clusters, and cluster on and off here as well.
Alright, I will now attempt to move both of the bulbs brightness all the way up. And cool. Turn them. Let's go ahead and just set the brightness all the way up again. And then turn them off and back on. Okay. I guess that's enough. And then let's try and move the first bulb down. And then turn it off and back on.
So here, Ricky is going to shortly discuss about the profile tab.
So the profile tab allows users to update their password and email, as well as input utility provider and budget, as well as number of floors per building. Here you can also register new smart devices via clusters, like if you want to, clusters is another word for groups. If you want to group together individual bulbs to a room, you can also register new bulbs, or just individual bulbs itself, because each bulb will have a unique identifier. The way smart devices work in this system is that we pull from an RESTful API that allows us to get JSON objects from the RESTful API to allow us to register the unique IDs and unique group names from the system. The way that it also works is that we have to connect a physical bridge to the GSU network to allow us to discover like individual bulbs to get us to be able to remotely toggle them and get their wattage output per second.
All right. So I'd say that that's the totality of our implementation phase. Moving on to testing. We've run into a couple bugs. One of which seems to be when we re-register users, they essentially lose the ability to log in. So we're working on that. Does anybody?
Other bugs that we have found is that a user may be registered 2 times, the same user may be registered twice. We are working on fixing, we are working on throwing alerts when the username or the password doesn't meet the requirements. We're also working on those. So those are things that we are hoping to fix by the deadline.
And all of our test cases and all that must be verified. We're making sure to verify physically with the smart bulb, verify with backend the SQL tables, as well as just ensure that the website just meets all of our functional and non-functional requirements. Thank you so much. I'm very proud of our group, and yeah, we hope you like our product.